Okay, before we go into the agenda, I'll start with introducing myself. So I'm Olga Loegel. I'm a user outreach and engagement associate at ECMWF, and I'm leading the organization of the AI Weather Quest. And I will be hosting this webinar today together with Joshua Talib, who will also introduce himself in due time. So let's start first of all, maybe with the agenda of today. We will go over presentations of the AI Weather Quest for about 30 minutes. We will start with reminding you what the AI Weather Quest is in a nutshell for those of you who were not present at the previous AI Weather Quest launch webinars. Then I will let Joshua Talib explain you a bit more what the testing period is, what is the structure and the outputs. And then he will go over a step-by-step guide of how to participate into the AI Weather Quest, also giving you relevant tips and information regarding technical support. I will then present you with how to engage with the quest during the testing period, but also during the competition phase, both with fellow participants and with us, the organizers. And then we will present you with a brief overview of the current number of registrations on the AI Weather Quest. And then we will have about 30 minutes, hopefully, of questions and answers. Before we dive right in, I have to remind you that this session is being recorded. So the recording will be made available online after the webinar. I will send you the link, of course. But if you do not wish to appear on the camera, please make sure to turn off yours. And please make sure also to mute your microphones during the presentation. But as we said, you will be very welcome to take to the floor during the Q&A and ask your questions out loud or directly in the chat, as you prefer. Okay, I think we can start with the AI Weather Quest in a nutshell. So as most of you must know by now, the AI Weather Quest is a global research competition. It's organized by ECMWF and it's endorsed by WMO. It's a competition for the best performing AI ML models for subseasonal weather predictions. And it's targeted at anyone who can leverage AI ML to improve weather predictions. So you don't need to have a meteorology background to participate. The competition is subdivided into two phases. We are currently into the initial training phase, which gives you time to develop and refine your models. We will soon enter on the 15th of May, the testing June, July, August period, on which you will be able to submit your forecast, but in a non-competitive environment. From the 14th of August onwards, we will enter the competition phase, where you will be asked to submit weekly real-time forecasts over at least for 13 weeks period, but you can choose to participate into any of these or all of these. Two important dates for you. On the 22nd of July, we will host another set of webinars, the pre-competition webinars, that will present you with how results will be displayed during the competition phase. And a very important date, the 1st of August, it is the registration deadline to partake into the first period, the first competitive period, the sun period of the AI Weather Quest, and thus to take part into the full year of the competition phase. So if you want to have a chance to be featured into the annual awards of the AI Weather Quest, you have to register before the 1st of August. In terms of what we are asking you to submit as forecasts, so we went into quite details about this on the first set of webinars, the AI Weather Quest launch webinars, which you will find the recording of on the website in the resources page. To remind you a bit, so during the competition phase and during the testing June, July, August period, you will be asked to submit global probabilistic quintile forecast at a 1.5 degree resolution. There are two forecast lead times, the days 19 to 25 and the days 26 to 32. You can submit forecasts for up to 3 different variables: the near surface to meter temperature, the mean sea level pressure, and the precipitation. And this forecast will be evaluated with a dedicated evaluation system against ERA5T using ranked probability skill scores. So as you see, I'm going quite quickly over this. This is because all the information is currently on the website and was already mentioned during the first set of webinars. So do not hesitate to scan the QR code that is on this slide if you want to access all the submission guidelines and information about the evaluation system. And do not hesitate, as I said, to go on the resources page of the website to watch the first launch webinars recordings in case you want to be reminded about the submission guidelines. But for now, we will go into more depth about the testing June, July, August period together with Joshua. So I will let Joshua present you with the structure of it.
Brilliant. Thank you, Olga. So as Olga says, my name's Joshua Talib. I'm within Frederick Furtad's sub-seasonal to seasonal research group. And I'm going to provide a brief overview of what we plan to achieve during the testing period that sits within the training period itself, as well as highlight some of the key components of the Python package that we've been developing here at ECMWF. So the testing period is a really exciting time where hopefully you've been developing AI machine learning based predictions on sub-seasonal timescales. And what we wanted to achieve during this over the next 13 weeks is for you to have the ability to trial forecast submission, to be able to visualize how your forecast will look like on an ECMWF style portal, and also self-evaluate those forecasts so you understand the skill scores that we'll be comparing forecasts against one another, but also for you to see how well your scores do compared to typical traditional dynamical models that we have here at ECMWF. So as Olga said, the testing period will last for 13 weeks. It's going to kickstart a week tomorrow, so on Thursday, the 15th of May. And you can see that essentially we're going to treat it as if it is a competitive window. So what I mean by that is we'll have the submission window open for 4 days, exactly the same as how we plan to have the competition phases of the AI Weather Quest. Then at day 5 of the forecast workflow, we will submit all of those models that have successfully been submitted to ECMWF and can work within ECMWF systems. We then have our 2 forecast periods. So this is week 3 and week 4 of the forecast workflow. And then finally on week 5, in day 37, so this is after the forecast periods itself. In the competitive phase, we will publish the leaderboards online. However, for the sake of the testing period, we will publish the ranked probability skill scores associated with the dynamical models so that you can compare with the scores that you get using your own predictions. So one thing to highlight here is that the testing period, whilst it may last 13 weeks, the competition component of the AI Weathercast begins on Thursday, the 14th of August, highlighted here in the bottom left. This actually means that because of the lead time between when the competition period starts and when you receive the evaluation date from the ranked probability skill scores, you actually only have 8 weeks to compare your scores with what you're predicting, with what you get from the dynamical models. However, you have 13 weeks to check that the forecast submission is successful. So I'd really just take this opportunity to say, use this testing period. Please test with the code that I've written that you can successfully submit to the AI Weather Quest, because during the competition phase itself, we won't be lenient if there are any issues on your side. We're going to be very strict. We need to receive a forecast for every week within each competitive phase for you to be eligible for awards at the end of each competitive period or across the whole year as a whole. So in terms of the testing period outputs, so these were briefly touched on when looking at the forecast workflow. So at day 5, so this is once that forecast submission window is closed, we will publish the names of the successful teams and their associated models that have successfully submitted a forecast to the AI Weather Quest. The way these team names and model names will be published is via an Excel spreadsheet that will be published on the AI Weather Quest forum, which Olga will introduce at the end of this presentation. In every Excel spreadsheet, you will see a design that you can see on the screen, where essentially for each variable and forecast window, we will separate out into separate sheets. And then within each sheet, we will show the competition week. So essentially at what point in the competition are we in, as well as the forecast initialization date. And underneath that, we will highlight the team name and the associated model name that successfully submitted a forecast to the AI Weather Quest. In addition, so following the actual period that we're forecasting, so week 3 and week 4, at day 37 of the workflow, so this is now every Friday, we will publish the scores from the dynamical traditional forecasts in a similar Excel spreadsheet format as the names of the submitted forecasts. At the moment, we're currently going to provide the forecast scores from the ECMWF IFS. However, we're hoping to expand this out to more of the dynamical models that are submitted to a WMO lead center portal here at ECMWF. So just to highlight, that gives you sort of a brief overview of how we plan to structure the testing period. I should say, and we'll go into a bit more detail later on, please don't hesitate to get in touch throughout any part of the testing period if you have any issues with submitting a forecast. So the next component of the webinar is to understand and to provide a bit more detail on the capability available through the AI WeatherQuest Python package that's been developed. So the Python package is set up into 3 components. These include forecast submission, forecast visualization, as well as forecast self-evaluation. For the rest of the presentation, I'm going to go into detail of how each of these components work, including the code that's needed to interact with these individual Python modules. Just to highlight, to use these tools, you must be registered to the AI WeatherQuest, and this can be done via the AI WeatherQuest website. We have also included, as well as this webinar, we have detailed read the docs documentation, which we'll put a link in at the end of the webinar for you to access. However, I'd highlight that if you do get stuck or you have issues, please look at this documentation, however, as it provides examples of how best you can submit a forecast. And finally, I'm just going to briefly explain to install the AI WeatherQuest Python package. You can use pip, and I recommend looking at documentation of how to install Python 3 and pip before running this command line, which will enable you to download the latest version of the AI WeatherQuest Python package. Okay, so the step-by-step guide. If we focus first on forecast submission. So to submit a forecast to the AI WeatherQuest, you should have an array which contains your forecast of a shape that is 5 quintiles, 121 latitude and longitude points, and 240 longitude points. When you have this array, you just need 4 lines of code for you to submit your forecast to the AI WeatherQuest. The first line of code essentially imports the correct Python module from the AI WeatherQuest Python package. The second line, you essentially create an empty X-array data array where essentially you provide us with the variable name that you are forecasting, the forecast initialization date, the selected forecast window, your team name and your model name, as well as the password that you received in your registration email when you registered to the AI WeatherQuest. Following this, you'll have an empty data array, which is configured so that it works correctly with ECMWF systems. And all we require you to do is to populate the values of that empty data array with the values that you have in your forecast. Just to highlight, I will be showing you this very quickly in a Python environment. Finally, and the final step is to then, once you've populated this empty X array, you can then submit the forecast to the AI WeatherQuest. And this requires the same variables as you had when creating the empty data array, with the addition of this populated X array that you see here labeled forecast. So just to highlight once again, line 4, you have the forecast submission when you call the Python function that's labeled AI WeatherQuest forecast submission. You give it the forecast that you've populated along with the variables that enables us to understand what you are forecasting. And then once again, you give it the password that you have received during within the registration email. Just to highlight, when you run this forecast submission piece of code, several checks will be performed. So, for example, to ensure that everyone is submitting forecasts at the same time, we check that the initialization date is a Thursday, and then it also sits within days 1 to 4 of the forecast workflow. We also check that the coordinates have the correct shape and the correct values. So, for example, that your latitude values go from 90 degrees latitude to minus 90 degrees latitude. And what we also do is we check that when we sum the quintile probabilities, so when we sum across all of the probabilities across the quintile axis, that these equal to 1 with a very lenient plus or minus 0.2 either side. There are additional checks that are also going to take place, and I recommend you reading the Read the Docs documentation for you to understand these checks in a bit more detail. Additionally, when you submit a forecast, you can also visualize this forecast and see how it will appear on an ECMWF style portal. And to do this, you just need your 2 lines of code with the addition of the forecast that you've submitted to the AI web request. So first, to do this, what you need to do is import the plotting forecast Python module. Similar to the forecast submission, you type out from AI web request package, import plotting forecast. And then I've just generated a simple function that will plot the forecast for a specified quintile number. So here what you do is you type in the Python function, you refer to the plot forecast function within that module, and then you give it the forecast that you have submitted to the AI web request, the quintile number that you want to plot, where in this case 1 refers to the first quintile, so probabilities below 20% of the climatology, 2 refers to between 20 and 40% of the climatology, etc. And finally, there's an option for you to give it a local destination on your computer where you plan to save the figure. However, this parameter is not necessary for the function to run itself. On the right here, you can see what this forecast looks like. So this is actually the 2-meter temperature probabilities of the highest quintile for the forecast that was initialized the first day just gone for week 3 of the forecast. So this is between the 19th and the 25th of May. You can see I've given it a team name of the ECMWF test and model name webinar test. And you can see here the probabilities of these extreme temperatures. And personally, I'm into research within the tropics, and we can see quite high probabilities of extreme temperatures across East Africa, as well as across the Indian continent. Just to highlight that this visualization code is only compatible with the arrays that are submitted to the AI web request. So please don't go ahead and try and input your own unique netCDF files. For example, we read what the team name and model name attributes are of the forecast that you submit. And just to highlight once again, the color maps, for example, that will appear on the screen when you use this function are similar to the forecasting portal that will be hosted at ECMWF during the competition phases of the AI web request. And then finally, just to highlight how forecast evaluation works. So during the AI web request testing period, you will be submitting forecasts, and we encourage you to use the code that we developed to work out the global ranked probability skill score that will also be used during the competition phases and displayed on the leaderboards, and will be how we compare individual contributions to the quest itself. So to perform your own forecast evaluation, what you essentially do is import the retrieve evaluation data and the forecast evaluation Python modules from the AI web request Python package. You then have 3 lines of code to import the appropriate data that is needed for you to perform your own forecast evaluation. So this includes the observations that occurred during week 3 and week 4 of the forecasted period. It includes the quintile climatology, so essentially where in the historical record do we see the 20th, 40th, 60th, 80th and 100th percentile, so that you can then fit the observations within the correct quintile bounds. And then finally, you can retrieve the land sea mask that is then used to essentially work out the skill scores over land points only. For each of these 3 imports of data that is used, you essentially need to give us the date, which for the AI web request will only work with a Monday start date, as well as the variable that you are planning to evaluate. So, for example, in a few weeks' time, you may choose to evaluate forecasts that were initialized on the 1st of May, so the previous Monday. So you would give us the respective week 3 start date, the variable. So in this case, let's say you wanted near surface temperatures, you would give us TAS, as well as the password that you've received in the registration email. You will then receive the observations or the quintile climatologies or the land sea mask. You'll be able to download this from the ECMWF system. And then finally, there are 2 lines of code that you need to run to work out the global ranked probability skill score. The first is this function called conditional obs probs, which essentially puts in the observations within the correct quintile boundary. And I've outputted this as obs PBS, so essentially observations probability. And then you use this observation probability, which is a matrix of where the observations sit within the quintile boundaries, to work out what the global ranked probability skill score is. So here you'll have your submitted forecast, you have your observations metric, as well as the variable and the land CMASC, and this will give you a single value which will show you what the ranked probability skill score is for the submitted forecast that you've inputted. Just to highlight, so the code that you can see on top is an example for the weekly ranked probability skill scores. So essentially the ability to compare one set of forecasts with one set of observations. However, in the read the docs documentation, there is an example of how to calculate the aggregated ranked probability skill scores, which will be used primarily to work out the winners of the competition. Okay, now we're going to do something very brave, is we're actually going to go live. So what I'm going to do is I'm going to show you under a Python environment how you can submit a forecast yourself, and hopefully you'll be able to see that it's quite a simple system. So what I've done here is I've run some initial code that essentially has downloaded the appropriate forecast data from ECMWF's dynamical model. So you should be able to see on the screen here, I have an array that essentially is storing the probabilities from the dynamical model from ECMWF for each of the quintiles of near surface temperature from a forecast run that was initialized on the 1st of May. If we have a look at the forecast shape, you can see here in the bottom right, I've just printed out the shape of that forecast array. Its shapes is 5, 121 and 240. And this corresponds to the individual quintile bounds, the number of latitude points, as well as the number of longitude points. So as Olga said in her slide, we're looking at a 1.5 degree resolution. So when you look at the number of latitude points this corresponds to, you have 121, and longitude points you have 240. Okay, so we have our array. It contains the forecasted probabilities. Now what I want to do is I want to submit a forecast to the AI weather quest. So what I do first is I import the forecast submission module of the AI weather quest Python package. The next stage is I want to open a empty data array. So with this forecast submission Python module that I've imported, I open up the AI weather quest create empty data array function, and I have 5 variables that I need to input. The first variable, the first parameter within the function is the forecasted variable. So in this example, I'm going to do near surface temperature. So we give it TAS. I'm then going to give it the forecast initialization date, which in this case is the 1st of May. The forecast window, so this is either a number that's 1 or 2, corresponding to week 3 or week 4. So in this case, I'm going to give it week 3 forecast, which is the first forecast window. I'm then going to give it the team name and model name. So in this case, I'm just doing a test. My team name is ECMWF test and my model name is webinar test. And finally, I'm going to give it that registered password that I received within the registration email itself, which here I'm calling password. I've already defined it. It will not be called password for you. So I then click enter with that function and you'll see several things that appear. So the first thing to appear is some checks that your model name and team name has been registered to the AI weather quest. Great, we can see here that ECMWF test has been registered, as well as webinar test has been registered to the AI weather quest. The next table you'll see is essentially what we've done is with your information that you provide from your team name and model name, we're essentially giving each forecast a unique identification. This is essentially to enable us to work with ECMWF systems in the future. So, for example, when we hope to put all the forecasts that we receive on Mars here at ECMWF, we need to give each forecast that we receive a unique identification. And you can see that the unique identification here on the screen. You'll also see, maybe you are included in this, that several of you have already tested the function and you have already received a unique ID that's associated with your team name and model name. I should highlight that as we give each forecast a unique identification, sorry, not as we give each forecast, as we give each combination of team name and model name a unique identification, the ranked probability skill scores across each competitive period and across the whole year will be based on this unique identification. So if you plan to submit and partake in the full year of the competition and would like to be awarded throughout the full year of the competition, please do not change the model name or team name associated with your submission. Once you change the model name associated with your submission, it will count as a new model, and therefore it will count as a different set of scores. So, for example, if I wanted to partake and wanted an award at the end of the year, I would have to submit the same team name and same model name throughout the full competition for me to be eligible for an annual award at the end of the competition. Okay, so we have now created an empty data array, and I called it forecast. So when we print out this empty data array, you can see that it has the dimensions of quintile, latitude and longitude, 5, 121 and 240 longitude points, the same as what I plan to input. You will then see that with the array within this data array is essentially empty. So the values that you see are either very low or very, very close to 0. Then at the bottom, you'll see an array of coordinates as well as a list of attributes. These coordinates help us understand what you're forecasting, including the issue date, the period start date, and the period end date, as well as the attributes associated with that forecast. So, for example, here we're forecasting the 2-meter temperature probabilities, and therefore we're giving this information within the X array itself. You'll also see that you have your unique experiment number as well as the team name and model name within this X array. So now what I want to do is I want to populate the values of this array with the forecast data that we had at the start. I have made an error. I've not called that forecast values. So what you do here is you essentially call the values component of this empty data array and you assign it with the forecasted array that you had at the beginning. So here all I'm doing is I've said forecast.values equals the forecast data that I'm giving it. The next component of the submission is calling that submission component of the forecast submission module, where essentially you give it the forecast and the same variables as we described previously. When you enter that, you should once again see a check that you are registered to the AOA request, both the model name and the team name. You'll see that there's a quick check of the coordinates are correct within the forecast that you're submitting, that all data is between 0 and 1. And then you should also see, once again, your experiment ID within the table of all submissions. And then finally, at the very end, you will see 3 lines of code. So the first line of code is essentially saying, we recognize your initialization date, and we're going to generate a folder here at ECMWF within the forecast submissions. You'll then see that it labels your forecast submission as a netcdf file, and it will essentially either say existing file has been deleted. So in other words, I've already submitted something to the AI web request and it's trying to re-upload it, so it deletes the old one and submits the new one, or you won't see this line, and in that case it's just uploaded the latest version that you had. So 4 lines of code to submit a forecast. I know we are very quickly running out of time, so I'm just going to quickly show you how to visualize the forecast yourself. So what you can do is you can import the plotting module of the AI Web Request Python package, and then you have 1 line of code that you can run to plot the forecast itself. So here what I'm doing is I'm calling the plot forecast function within the plotting forecast module. I'm calling the forecast that I submitted to the AI web request. just change that to forecast submit, and I'm calling the fifth quintile. So this is the quintile that's within 80 to 100%. When I enter that, you can see that it's not produced any output. What I can do is I can go to my working directory and I can display the latest forecast that is just been computed. If you give me one moment. So display, you can see on the screen here, essentially the forecast that I was showing you in the PowerPoint slides. So these are the 2 meter temperature probabilities for the forecast initialization date of the 1st of May for week 3. Once again, using the team name and model name attributes that are contained within the submitted forecast that you give. I'm not going to go into detail of how the forecast evaluation works. However, if you follow the slides or the read the docs documentation, you should be able to perform your own forecast evaluation using the code provided. So finally, just a few tips from me from a technical point of view. Please check that the inputted variables that you submit to the AI WeatherQuest Python packages match the same variables that you have given to the registration. So what you registered on the AI WeatherQuest website. I should also say, please update to the latest version of the AI WeatherQuest Python package. As of this morning, I've just released version 2 of the AI WeatherQuest Python package, and you can use the function on the screen to upgrade to the latest version. As I've said many, many times, there are detailed step-by-step guides of how to use the functions that we've developed in the Read the Docs. And finally, throughout the testing period itself, we've got 13 weeks to make sure that we have a working system. Please don't hesitate to get in touch, whether that's via the forum or email, if you have any issues, and we'll aim to respond to those queries as quick as possible. Okay, thank you for listening. I'm now going to pass over to Olga, who's going to introduce the best ways to engage with the quest. Over to you, Olga.
Thank you, Joshua. That was great. As Joshua mentioned, during the quest, we will engage with participants, and you can engage one with the others with help of the dedicated AI WeatherQuest forum. So you can access the forum by simply scanning the QR code on this slide, or you can also access it with a dedicated button on each page of the AI WeatherQuest website. So once you go on the forum, you will be able to view any topics that are already existing there without necessarily logging in the system. You can first check the instructions topic that was created by me with instruction on how to engage with the forum, notably using the 5 tags that we implemented there. 1 is for us, the organizers' announcements, but 4 are for you that you can use. 1 to find teammates, 1 if you want to initiate discussions between teams, 1 to ask us general questions, and 1 to ask us with technical questions. So you can just start any new conversation and assign the relevant tag for it to appear on the forum. First, you will just need to be logged in with your ECMWF account. Don't worry if you don't have one yet, you will be proposed to create one. And as Joshua was mentioning, this forum will be heavily used during the testing period. You will be able to check then every Mondays the names of the teams and model for which forecasts have been successfully submitted. And every Fridays, you will be able to check the RPSS for the dynamical models to compare it with your own results. If you have any individual matters for which you need to ask us questions, you can also reach out to us through the contact form. And if you are not willing to directly participate in the quest, but would like to keep up with the quest as an observer, you can subscribe to the newsletter. Both the contact form and the newsletter are on every page of the AI WeatherQuest website at the end of every page. Moving forward to the last slide, that's a call to action for you. Joshua, I can let you change slide. We have at the moment more than 260 number of registrants to the quest that are part of more than 100 teams. So as you can see, it's a huge success at the moment, and we want to see everyone who thinks that they can participate in the quest join in. So if you haven't registered yet, keep in mind the August 1st deadline that will enable you, if you registered before, to compete across the full competition period, to take part into the first period, and thus be eligible to be featured into the annual awards leaderboards. And now I think it's the time to move to the question and answers. So feel free to ask any question. You can simply raise your hand if you want to unmute yourself and speak out loud, or you can type a question in the chat and we will read it and answer to it. I already see that, Pierre, you said that please kindly share the presentation with us. Indeed, as for the first webinars, the presentation, the recordings will be shared with you. They will be on the resources page, and I will send you a dedicated email with the links as well. So are there any questions? So Nidhi Gopal is asking, can we use JetBrains Community Edition? Joshua, do you know about this? PyCharm JetBrains Community Edition for Python programming.
I only have experience of this many years ago. So if you can, if PyCharm JetBrains allows you to import the latest version of their web request Python package, then you're very welcome to use PyCharm to write your code. Maybe, yeah, thank you. So maybe if you could try and download the Python package in a JetBrains environment and let us know how you get on. And if there are issues, then we can look at that into a bit more detail.
Okay, we have a participant saying that despite him being excited about the competition, he's still looking for a team. And are there any team looking for extra hands? So maybe, Joshua, if I'd let you go on 2 slides before. As I was presenting the form, you will notice there is a dedicated tag to find teams. So if you scan this QR code and go on the form, I believe already one or two participants have reached out saying that they would themselves like to join efforts with other participants. So do not hesitate to just join the forum, answer directly. You can private message this participant. You can answer directly on their topic on the forum. Or you can create your own topic to present yourself and say that you are willing to engage with fellow participants to create a team together. So there definitely are other people looking to join efforts. Then we have one participant asking, what would be the typical dates for which we would be conducting the predictions? For example, the competition starts on August 1st. Then we predict for August 14, 15 kind of week. Yeah, Joshua.
Yeah, so maybe, I mean, this is highlighted a lot more in the welcome webinars that you can find online on the AI Web Request Python packet, on the AI Web Request website. But maybe just to highlight here, so in the top right, you can see the forecast submission workflow. And essentially, the submission window is open during days 1 to 4, and forecast submitted during this period should forecast for week 3 of the forecast submission workflow. So this is days 19 to 25, and days week 4, days 26 to 32. Now, what does this actually mean in reality? If you look at the bottom row of the table, you can see here that the forecast submission window, so this is for the first competitive week. So the first competitive week starts on the Thursday, the 14th of August. And essentially it's forecasting for week 3, which in this scenario starts on the 1st of September, as this will correspond to the SON competitive phase, as well as the week 4, which starts on the 8th of September. So essentially the forecast submission window opens here on day 1, and then you have the week 3 and week 4 commencing dates here. And then finally for the competition phase, as well as the testing phase, there'll be a publication of the scores on day 37, which occurs approximately 5 days after the end of week 4. Just to also say, on the website, you can get a full list of all the initial forecast dates, as well as the week 3 and week 4 commencing dates on the website itself. But if you need any more information about this, just please don't hesitate to get in touch. Back to you, Olga.
Yes, exactly. And the link that Joshua just mentioned, that's the link I shared in the message in the chat, so you can access the full forecast schedule dates there. Then Nidhi is asking, what are the advantages of taking part in the quest? And is it limited to weather forecast readings only, or can other types of data such as precipitation and rainfall measurements also be included? How safe and secured will be the data after the quest? So I will start with answering the first message. As you know, there's no monetary prize in the quest. The main objectives for participants is to gain recognition, be able to submit forecast in an operational-like environment, improve their expertise on the AI and ML for weather forecasting, and of course, engage with fellow experts in that domain, notably from ECMWF. For the second question, I think, Joshua, you can answer. Is it limited to weather forecast readings only, or can other types of data, such as precipitation and rainfall measurements, also be included?
So to train your machine learning model, you are able to use any data set. We are focusing on quintile probabilities for the forecast. So, yeah. And then how safe and secure would the data be after the quest? So at the end of each competitive period, we are planning to make all the forecasted probabilities available to all. So, and the plan is basically to enable collaboration and research of the submitted forecasts. However, these forecasts will not be available to all during the competition itself, or during each competitive phase individually.
Yes, I think it's also important to say that we will not ask for the code themselves. It's just about the data that is being submitted. Another question is, we can use the Air Weather Quest library to set up the model, like training it for historical timeframes and setting it up. Also, to add on to the before, how is the Python model verifying the prediction verified using observational data?
Okay, so to answer the first question, you are very welcome to use the modules within the AI Weather Quest library for training. However, you won't be able to access a full catalogue of observations and historical climatologies. So here at ECMWF, we're regularly downloading the appropriate observations and historical climatologies. And I think for testing, it goes back 3 months. So I would not recommend using the package to download a historical set of observations if you want to train a model. Also to add, so Olga briefly presented how the forecasts are being verified. Essentially, we are comparing the forecasts that are submitted with the latest outputs from ERA 5T. So what we do is we work out what the where the observations sit in the quintile historical climatologies of ERA 5T to work out what the global ranked probability skill scores are for each of the submitted forecasts. However, I'd highlight, if you want to understand this process, please look at the website and also the welcome webinar as we go into a bit more detail about this process.
Okay, do we have any other questions? You can also take to the floor if you want to ask your question out loud. Okay, in the meantime, for the last question, that was the second to last question, that was about how safe and secure would the data be after the quest. I think it's also important I refer you to the terms and conditions that I will share in the chat. So before you register, of course, do not hesitate to read through them. Do we have any remaining questions? Maybe in the meantime, Joshua, I can ask you a question. So you said that some participants already successfully submitted some forecasts, right, to test the system?
Yep. Yeah,
okay, just wanted to know if that worked.
I've not looked into detail, but there are clearly some individuals who have tried to submit a forecast and have successfully received their own model ID. I mean, once again, just to clarify, once you have given us a team name and model name, if you want that model to be eligible for the full year, do not change that model name. Because otherwise, sorry, go on.
No, I think we didn't have any other questions, so I think we can go to the last slide. I will start, of course, with saying a big thank you to everyone involved in the organization of the AI Weather Quest, and then to remind you that we have an upcoming webinar on the 22nd of July. So I'm sharing with you right now the registration links. This webinar will help you get ready for the competition phase, because we will transfer from a non-competitive to a competitive environment, meaning that your results will be displayed. So we will show you exactly how we plan on displaying the results, how we'll plan on setting up the leaderboards, and also how we plan on making your forecast visualization so that anyone can visualize the forecast that you send through the AI Weather Quest. So please join us on July 22nd. Similarly to today, there will be a morning and an afternoon slot, and you can register as soon as today through the links I just sent on the Teams chat. Thank you very much all for your participation, and you will have the recordings soon. I hope to send you an email by the end of this week or the beginning of the next one. Thank you.